Question 2. A car starts from rest at a checkpoint A and comes to rest at the next checkpoint B, 6 kilometers away in 3 minutes. It has first a uniform acceleration for 40 seconds, then a constant speed, and is brought to rest with a uniform retardation after 20 seconds. Sketch a velocity time graph of the motion. That's the first question. Then we are asked to determine the maximum speed and the retardation. This is NECO 2003. Okay, please, I want to pay attention. Now let's draw the graph. Let's first draw the graph. Okay, now the car starts from a checkpoint A. Okay, so I'm going to call this A, and then it comes to rest at the next checkpoint B. So I'm going to call this what? B. You understand? So 6 kilometers away in 3 minutes. That is the total distance that is traveled is what? 6 kilometers. You understand? That is the distance between A and B is what? 6 kilometers. So we've been given the distance. So the distance from this point to this point is what? 6 kilometers. Do you understand? See, you have to learn how to interpret the question. Okay? Now, in 3 minutes, the total distance that the cars travel is what? 6 kilometers. Now, the time taken to travel the distance, the total time taken to travel the distance is what? 3 minutes. So, let me just put it here. Time taken, okay? Time taken is equals to 3 minutes. Total distance is equals to 6 kilometers. Now, let us proceed. It has first a uniform acceleration for 40 seconds. Don't forget that I told you that when this graph, we have these three graphs. This is when the object is moving with a constant velocity. You understand? It's not accelerating at all. Now, this is the graph when the object is accelerating. You understand? Now, we are told in the question that this object is first accelerate for 40 seconds. You understand? So, since we know that this is the graph for an object that is accelerating, so I'm going to have something like this. Accelerating from rest. Do you understand? Okay? Now, we are told that the time that it's used to accelerate is what? 40 seconds. So, from this point to this point is what? 40 seconds. Do you understand? Okay? Now, then a constant speed. That means that after it accelerates uniformly for 40 seconds, then it maintains a constant speed. And I told you that among this velocity time graph, if the object is traveling with a constant velocity or constant speed, you understand? You know, in velocity time graph, speed and velocity is used interchangeably. You understand? So whether they talk about speed or velocity, it's also the same thing here. Okay, with respect to what we are dealing with now. Okay, now so I told you that when the velocity of an object is constant, then this is how the graph will look like. You understand? So from this point, the graph will look like this. We are not told the time the object used to travel at a constant speed. You understand? So let's proceed. And it's brought to rest with a uniform retardation after 20 seconds. That is, after 20 seconds, the object is brought to rest. Now, please pay attention. Look at that statement. Then a constant speed and is brought to rest with a uniform retardation after 20 seconds. That is, after maintaining the constant speed for a particular time, the object, okay, the car now is now brought to rest after 20 seconds. That means that the time after reaching this point, after traveling from this point to this point with a constant speed, it is now brought to rest. You understand? The time between this point and this point, okay, let me trace it. We don't know the time here. The time between this point and this point is what? 20 seconds. Okay, 20 seconds. Do you understand? Now, we don't know the time taken from this point to this point. Please pay attention, okay? We are told that the car is brought to rest after maintaining a constant velocity for a particular amount of time. We don't know the time. You understand? But we are told that it is brought to rest after 20 seconds. That is, the time taken from this point to this point is what? 20 seconds. Now, we want to determine the time taken from this point to this point. That is from this point to this point. Okay, let us put a letter. This is A, B, C, D. Okay, let's put it as E and F. Okay, A, B, C, D, E, F. Now, we've known the time that the car used to travel from A to E. That is 40 seconds. Now, we need to determine the time that the car used to travel from E to F. You understand? So, don't forget that we've been given in the question that the total time taken is what? 3 minutes. Okay? Now, we want to change 3 minutes to seconds. That will be what? 180 seconds. You understand? 3 minutes to second. That is, if 1 minute is equals to 60 seconds, 3 minutes, let it be equals to what? X. Now, if you take the cross product, we're going to have X is equals to 60 multiplied by 3. That is what? 180 seconds. So, the total time taken is what? 180 seconds. Now, let the time that the car used to maintain the constant velocity, let it be X. Okay? So, X plus 40 plus 20 must be equals to 180. Do you understand? Because the total time taken has been given from the question, which is 3 minutes. And when we change 3 minutes to seconds, we got what? 180 seconds. Okay? So for this, I'm going to have X is equals to 180 minus 40 plus 20, that is 60. If 60 moves to the other side of the equation, okay, let us do it step by step. Let's do step by step. Plus 60 is equals to 180. So X is equals to 180 minus 60. Minus 60, okay? So X is equals to 120, okay? So the time taken from this point to this point is what? 120. You understand? Please understand how I'm solving the question so that you won't get confused. The time taken from this point to this point now is what? 120 seconds. Please pay attention. Now, if I want to get the time taken from this point to this point, that will be what? 120 plus 40. Do you understand? Please pay attention. The time taken from this point to this point is what? 40 seconds. And the time taken from this point to this point is what? 120 seconds. Now, if I want to get the time taken from this point to this point, it will be what? 120 plus 40 seconds. That will be what? 160 seconds. So, here I'm going to have 160 seconds. Do you understand? And if I want to get the time taken from this point to the total time taken, that will be what? 180 seconds. Okay? Let me put it as B. 180 seconds. Do you understand? So I can erase this. I can also erase this now. Do you understand how I got this? If you do understand, reverse the video and watch it again. Okay? It's simple. Now, we have drawn the graph. This is the graph that we are asked to draw. This one, you already have a mark. Okay? Now, don't forget that the velocity is here, meter per seconds, and we have the time here in seconds. This is the velocity. Velocity that the object reach is what? Here. You understand? This is the velocity reach in meter per seconds, okay? We don't know the velocity, okay? We are asked to determine that velocity. If you look at the first question here, determine the maximum speed. The maximum speed is also the same thing as maximum velocity, okay? I've already told you that in this in velocity time graph, both velocity and speed are used interchangeably. You understand? They are used interchangeably. So when you talk about speed, just know that we are also talking about velocity. Now, this is the velocity this is the maximum velocity. We don't know the value of the maximum velocity. Now we are asked to determine it. The maximum velocity is the velocity from this point A to this point. Please pay attention. The maximum velocity, pay attention, is the velocity from this point to this point. That's why I got this line. You understand? So let us represent it as let's represent it as V. Okay? Do you understand? Now, you can see that this distance is equal to this distance is also the same thing as this distance. And it's also the same thing as what? This distance. Please, you have to be able to interpret question. This distance, you can see this distance that I have here is also the same thing as distance CE. And it's also the same thing as what? Distance DF. You understand? Now, we are going to use the area to determine the velocity, the maximum velocity. You understand? The area of this shape will give us we are going to use it to determine the maximum velocity. Now, let me ask you a question. What is the name of this shape? Forget about the sketch line, okay? Forget about the sketch line now. Forget about this, all this sketch line. You understand? Look at the deep line, okay? Forget about the sketch line. Don't focus on the sketch line now. What is the name of this shape? This shape like this. This is the velocity time that we have. You understand? What is the name of this shape? The name of this shape is what? Trapezium. You understand? Now we're going to use the formula of trapezium to determine the area. You understand? Our area will now lead us to the value of our v, which is the maximum velocity. You understand? Now, area of trapezium is given by half multiplied by c. Please pay attention. From this point to this point is what? 180. Okay? Pay attention. From this point, we don't know the value. We don't know the value here. You understand? And from this point to this point is what? From this point to this point is what? 120. Do you remember? So this is what? 120. From this point to this point, 180. From this point to this point, 120. Now, we do not know the value of this. So let us represent as v. You understand? Because this line is the same thing as this line. You understand? So let us represent it as v. Okay? Now, don't forget, in the question, we've been given that the total distance traveled is what? 6 kilometers. I hope you remember. We've been given in the question that the total distance traveled is 6 kilometers. And if you want to get the area of a velocity time graph, if you want to get the distance traveled of velocity time graph is the area. You understand? The area of a velocity time graph gives us the total distance traveled. Do you understand? Please, that's another point that I want you to note. The first point is in the previous question, that when you are asked to calculate the uniform acceleration of a velocity time graph, the uniform acceleration is also the same thing as the slope. Now, I'm giving you another point now. Note this point. The area, the total distance traveled in the velocity time graph is equals to the area. You understand? Now, the total distance traveled given to us in the question is 6 kilometers. Now, we know that velocity is measured in meter per second. So, we cannot use 6 kilometers directly. We have to change to what? Meter. So, now let's change 6 kilometers to meter. Don't forget that 1 kilometer is equals to what? 1000 meters. You understand? Now, let 6 kilometers be equals to x. If you take the cross product, you're going to have x is equals to 6 multiplied by 1000. 1000 meter. That is what? 6000 meter. Okay? So 6 kilometer is what? 6000 meter. Now, we can now use the formula to determine the area. To determine the velocity. Okay? In this case, the velocity is the maximum height. Pay attention. The area of a trapezium. Area of a trapezium. The area of a trapezium. I want to do all this, okay? Don't mind my head. The area of a trapezium is what? Half into bracket a plus b multiplied by h. You understand? This is the area of a trapezium. Now, a is the length side, the side that is long in the trapezium, and that's it. B is the second side, the parallel. You see, A and B in the trapezium are the parallel side. You understand? The first parallel side is A, and the second parallel side is B. You understand? And H is the height. You understand? Now, I've already told you that when we are dealing with area in the velocity time graph, area is also the same thing as what? The total distance traveled. Now, for this, I'm going to have 6000 meters. 6000 is equals to half multiplied by A. A is what? 180. 180 plus B is what? 120 multiplied by H. H is what? The maximum velocity. You understand? That's what I want to know. The maximum velocity is the H, because from this to this point, that's the maximum velocity of the car. You understand? And it is also equivalent to the distance from this point to this point is also the same thing as what? The distance to this from this point to this point. You understand? And since we are dealing with a trapezium, trapezium always have height. As you can see, this is the height, this is the height, and the height of this trapezium is equivalent to the maximum velocity. You understand? So now I'm going to have v. Okay, so let's calculate the value of v. For this, I'm going to have 6,000 is equals to 180 plus 120. That will be what? 300. So I'm going to have 1 over 2 multiplied by 300 multiplied by v. Okay, so 6,000 is equals to 300v all over 2. So 6,000 is equals to 150v. That is the velocity. Divide by 150 over 150. So velocity is equals to 40. So that will be 40 meters per second. You understand? That is the maximum speed or velocity. Okay. Now let us determine the retardation. Don't forget that retardation simply means negative acceleration. It is the kind of acceleration that brought the motion of an object to rest. Okay. Now the retardation is the slope ds. You understand? That is the retardation. You know, we are told that the car retard, having maintained a constant speed for 120 seconds, it now undergoes a retardation after 20 seconds. You understand? So it is brought to rest after 20 seconds. That means that the slope here, the slope of this line is the retardation. You understand? So I want to pay attention. To get the retardation R is equals to, I want to pay attention. Okay? So to get the retardation DE, you understand? The retardation, which is this line, to get it, we are going to use the slope. You understand? And the slope is calculated by taking the difference rise over run, that is change in V all over change in the distance that at which the car used to retard. You understand? So for this, I'm going to have 0. The retardation will be DE, that is DF all over FB. You understand? DF, you know DF all over FB. I represent this point as F and this point as B and this point as D. You understand? So DF, which is the distance between this point and this point, and FB, distance between this point and this point. Okay? Now don't forget that the distance between this point and this point is also the same thing as the distance between this point and this point. Hope you remember. And we have already calculated it as what? 40. So I'm going to have 0 minus, okay, that will be 40 minus 0. Sorry. 40 minus 0 all over FB. That will be what? 180 minus 160. Okay? So for this, I'm going to have 40 all over 180 minus 160. That is what? 20. You understand? So the retardation is equals to that will be 2 meters per second. You understand? So that is the solution to that first question. Please, if you didn't understand the concept of retardation, you can proceed back to our class on uniformly accelerated motion. There, I explained the concept very well. You understand? So that is how to calculate the retardation. You understand? Retardation and acceleration is always associated with slope. You understand? Pay attention. Retardation and acceleration is always associated with slope. Do you understand? So that is the retardation of the car. That is 2 meters per second. Okay, I'm very sure you understand the class. If you didn't understand the class, let me know in the comment section. And if you understand, kindly let me know in the comment section. Okay, give me the feedback. Okay, see you in the next class. To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay, see you in the next class.